Good evening, sir. I am B. Sai Chand and I am studying in Institute of Aeronautical Engineering College. And my roll number is 21951A12669 and I am from IT Department B section. So today's topic is programming for everyone. So how do computers know that what we want to do? So in this chapter we are going to cover what makes a language and how does we use language to communicate with each other and with computers. So how did computer programming languages evolve? How do computers understand what we are telling them to do? What are the steps involved in building a program? How can we create something that would be visible on the World Wide Web? So, communications cycle. So, one complete unit of communication. An idea is to be sent, an encoder, a sender, and a medium, a receiver, and a response. So, these all involved in a communication cycle. So, a speaker encodes information. So, a listener decodes the information, and listener returns feedback to the speaker. This is the cycle in communication with a computer. So substituting a computer for one of the people in the communication process is basically the same. Response may be symbols on the monitor. So a user encodes the information, computer decodes the information, and computer returns result to the user. This is the process between the computer and the user. So a breakdown can occur any place along with the cycle between two people. So the person can't hear you. The phone connection is broken in mid call, and one person speaks only French while the other only speaks only Japanese. So these are the breakdowns that can occur when you talk with a person, and between a person and a computer, the possible breakdowns may are the power was suddenly interrupted, and an internal wire became disconnected, and a keyboard malfunction. So these are the basic interruptions that may occur between person and a computer. So when communicating instructions to a computer, areas of difficult are often part of the encoding and decoding processes. So programming languages bridge the gap between human thought process and computer binary circuitry. So programming language, a series of specified defined commands designed by a human programmer to give directions to a digital computer. So commands are written as a set of instructions called programs. All programming languages instructions must be expressed in binary code before the computer can perform them. So generally programming languages are in high level languages. So uh, we will compile it through the compilers to the binary language like machine understandable language. So in the programming languages, in the beginning, early computers consisted of special purpose computing hardware. Each computer was designed to perform a particular arithmetic task or set of tasks. So skilled engineers had to manipulate parts of the computer's hardware directly. Some computers required fat fingering. So fat fingering means engineer needed to position electrically relay switches manually. So others required program to be hardwired. Hardwiring means so using solder to create circuit boards with connections needed to perform a specific task. So ENIAC so used programming to complete a number of different mathematical tasks. Programming were entered by plugging connectors cables into the sockets on a plug-in board. Setup could take hours, so a program would generally be used for weeks at a time. So in the beginning, to use a computer, you needed to know how to program it. Today, people no longer need to know how to program in order to use the computer. So to see how this was accomplished, let's investigate how programming languages evolved. First generation, so machine language, the code. In the second generation, the assembly language came into. And the third generation, people oriented programming languages. So in the fourth generation, non-procedural languages. Fifth generation, natural languages. So the first generation, machine languages. So machine languages programs were made up of instructions written in binary code. So this is the native language of the computer. Each instruction had two parts, operation code and operand. So operation code, opcode, the command part of the computer instruction. So the operand, the address of a specific location in the computer's memory. So hardware dependent, could be performed by only one of the type of computers with a particular CPU. The second generation, assembly language. Assembly language programs are made up of instructions written in memories, not memories, mnemonics. So mnemonics used convenient alphabetic abbreviations to represent operations codes and abstract symbols to represent operands. So each instruction had two parts, operation code and operand, hardware dependent. So because programs are not written in ones and zeros, the computer must first translate the program before it can be executed. So the third generation, people oriented programs. Instruction in these languages are called statements. So high level languages use statements that resembles English phrases combined with mathematical terms needed to express the program or task being programmed. Transportable, not hardware dependent. Because programs are not written in ones and zeros, the computer must first translate the program before it can be executed. Pascal example, read in two numbers, add them and print them out. So this is the program sum to input output variable. So the num1 num2 integers begin, program begins the read of num1 and num2, sum is equal to num1 plus num2, write ln sum of end, the code is done. The fourth generation, non-procedural languages. Programming like systems aim to at simplifying the programmer's task of imparting instructions to a computer. Many are associated with specific applications packages, query languages, report writers, and application generators. So, what are query languages? Enables a person to specify exactly what information they require from the database, usually embedded within database management programs. So, report writers tasks information retrieved from database and formats into attractive usable output. So, application generators, a person can specify a problem and describe the desired results. So, included with many microcomputer programmings. The fourth generation non procedural languages. So, object oriented languages, a language that expresses a computer problem as a series of objects a system contains, the behavior of those objects, and how the objects interact with each other. So, the object, any entity contained within a system. Examples, a window on your screen, a list of names with your wish to organize, an entity that is made up of individual parts. Some popular examples are C++, Java, Smalltalk, and Eiffel. Fifth generation, which are natural languages. Natural languages, language that are ordinary conversion in one's language. Research and experimentation towards this goal is being done. Intelligent compilers are now being developed to translate natural language spoken program into structured machine coded instruction that can be executed by computers. Effortless, error free natural language programs are still some distance into the future. So, assembled, compiled, or interpreted languages. These are basically three processes. So, all programs must be translated before the instructions can be executed. So, the computer languages can be grouped according to which translation process is used to convert the instructions into binary code. So, the three basics are assemblers, interpreters, and compilers. So, programming for everyone. Several ways to control what your computer does or the way it accomplishes. Several ways to control what your computer does or the ways to accomplish a particular task using macros, using HTML to create web pages, and scripting. Each allows customization of current applications. Using macros. A macro, a set of operations within the computer application that have been recorded for later execution. Once recorded, the macro can be used repeatedly on any document within the application. In other words, processes. Macros are commonly used to speed up repetitive tasks. Example, SIG can be stored as a macro that includes a signature message at the end of the document. So using a HTML to create a web pages. HTML, hypertext markup language. So a computer language consisting of special codes intended to design a layout or markup of a web page. So web browsers interpret the HTML code and display the result web pages. So web browsers, a program that displays information from the World Wide Web. So each line of HTML is called a tag, formatting instruction. So these are the basic tags in the HTML. So this HTML in the codes is used for design a HTML document. So head is used for beginning of the header section, and title is used for the title bar, and slash head is for the end of the header section, and h1 is the latest text size, h6 is the smallest. So these are the examples of the tags used in HTML. So scripting, a series of commands written to accomplish some task, very similar to the concept of programming, extends the capability of application where it is being used. Examples of scripting languages are Perl, C++, VBScript, JavaScript. JavaScript, a scripting language that allows the web page designer to add functional features to the formatted web page created in HTML. So building a program, whatever type of program needs to be solved, a careful thought of outplan attack called the algorithm. It is needed before a computer solution can be determined. Developing the algorithm, writing the program, documenting the program, testing and debugging the program. So these four processes are basically occur in the building of a program. So next, developing the algorithm. Algorithm, a detailed description of an exact method used for solving a particular program. So to develop the algorithm, the programmer needs to ask what data has to be fed into the computer, what information do I want to get out of the computer. So logic, planning the processing of the program. It contains the instructions that cause the input data to be turned into the desired output data. A step-by-step program plan is created during the planning stage. The three major notations for planning detailed algorithms: flowchart, um, Naive Kirchner chart, and pseudocode. Series of visual symbols representing the logical flow of programs is known as flowchart, and pseudocode, a verbal shorthand method that closely resembles a programming language but does not have to follow a rigid syntax structure, is known as pseudocode. So this is the flowchart of building a program. Writing the program. Writing the program. If analysis and planning have been thoroughly done, translating the plan into a program language should be easy task. Documenting the program. So during both the program development and program written stages, explanation called documentation are added to the code. Helps user as well as programmers understand the exact procedure to be performed. Testing and debugging the program. The program must be free of syntax errors. The program must be free of logic errors. The program must be relatable, means produces correct results, and the program must be robust, able to detect execution errors. So, what is alpha testing and beta testing? Testing within the company. Beta testing means testing under a wider set of conditions using sophisticated users for the outside the company. So, what's the summary? Here's the summary. We traced the evolution of computer programs from machine code to high level language. We spoke about object oriented languages and why they are used today. And we discussed assemblers, compilers, and interpreters. So, we talked about the step needed to create a program. We concluded by describing the various types of testings. So, that's all in this presentation. Thank you.